So when I was 8 years ago, I went to the Amazon in northern Ecuador. I had just finished my master's studies in chemistry. I'd worked 1 year in a temporary position, and I'd saved some money. I was 24 years old, and I wanted to do something different. So I found a project I could volunteer for that was working on biological solutions for the large pools of crude oil that you see here that was left from decades of drilling for oil without proper regulations. And unfortunately, that problem was a bit too hard to solve in the few months I was there, but I left with renewed inspiration for how to work with the environment. And something I learned about was Terra Preta, which is a very fertile soil that's mined from certain parts of the Amazon. And it's quite interesting because most tropical soils have little organic matter. And falling biomass is quickly converted, and they grow more biomass or washed away. And you can see roots and trees that grow up mostly above the soil, and here with parts of the volunteer team. And the Terra Preta is fertile and high in organic matter, despite this tropical climate. So archaeologists found that it was created over centuries from large indigenous communities that were composting their waste together with charcoal. And after this discovery, the research on the use of charcoal in soil and for many other applications has skyrocketed. And another reason for that is climate change, because Terra Preta showed us that charcoal in soil was lasting for centuries. And it's still black and fertile in the tropics today. And those 20 years now that's been with intense research on this charcoal or biochar that it's called when it's made from biogas mass has established that it degrades very slowly. So if you think of a forest, here in Norway, every spring new leaves sprout, and that's actually trees. They take energy from the sunlight, and they take food from the CO2 in the air, and they make new leaves. And in the fall, this falls to the ground. They can even seem to pile up, but it just takes a few months and it's gone. And what happens is that organisms in the ground, they have a feast on these leaves. They use the sunlight energy in the leaves for their processes, and then most of the leaves turns into CO2. But CO2 from this decaying biomass is not really a problem for climate change because it's already been captured from the atmosphere and is being used for growing new plants. And we also call energy production from biomass climate neutral because it's being used and it has been used. And this is, if I want some energy in my cabin to get warm, it's still climate neutral. If we stop some of this biomass from turning into CO2 for centuries, like what we do when we make biochar, that was still taken from the atmosphere, so we get carbon capture through plants and carbon storage through biochar. And since my time in the Amazon, I always had biochar in the back of my mind. And so when I got the opportunity to work with Scanship R&D team, this is from our first summer party, and USN, I was thrilled to be able to work with this process. And some of you might know Scanship. It's now called VOW in the Stock Exchange. They have a large office here in Tønsberg, and they are specialized in waste treatment systems for cruise ships. But the research and development team, we work with future waste solutions and also on land. And this is one of the small version of the machines that I've been using in my PhD. It does pyrolysis, which is this process to make biochar. And this is from when I made biochar with my family. We just took water in our bonfire, and then you end up with char because it's the heat that's making the char instead of using oxygen to burn it up. So you remove the oxygen. In a controlled process, like what we do in the machines that VOW sell, we're making biochar, but we also make gas. And this gas contains many different gases and also condensate, liquids with hundreds of chemicals, like I've been working with here. And this is something I'm working to convert into biogas. And biogas, you might know this magical factory. It's just 10 kilometers from here. All of our food waste here in Tønsberg is converted in these bioreactors to biogas into bus fuel. This is a small lab bioreactor that we've built up in USN Porsgrunn, where I'm based with my PhD. And these can also work its magic on these condensates and gases. And this, of course, has a lot of challenges, and that's why we need research, and I'm trying to do a PhD on this. So even though I wasn't able to solve and remove all the oil pools in the Amazon in the 3 months I was there, now I have 3 years together with VOW and USN, where I can make a contribution towards a fossil-free future and biological carbon capture. And that can give us more time and tools to transition to a fossil-free world. And that hopefully that future can bring a time where rainforests can expand instead of being destroyed from mining and drilling for fossil resources. Thank you.